Learn fiber optics with Senko. Welcome to the connected world. Every day, roughly 2.5 quintillion bytes of data, voice, and video are transmitted all over the world, enabling our modern life. In order to transport all of this information, billions of kilometers of fiber are deployed around the world like the artery of global telecommunication networks. This is due to its advantages over copper cables, such as its greater bandwidth, immunity to interference, ability to reach longer distances, overall better reliability, and it is also thinner and lighter. Let's learn more about the optical fiber and how it is made. Basically, an optical fiber is a very thin strand of glass about the same diameter as a strand of hair. Pretty impressive, isn't it? To the naked eye, all optical fibers may look the same. However, that's not the case. There are many different types of optical fibers, each with their own specific application. Some examples are the single-mode fiber, multimode fiber, dispersion-shifted single-mode fiber, non-zero dispersion-shifted single-mode fiber, and bin-insensitive single-mode fiber. All of them have a similar basic structure, which is a core in the middle and a cladding around it. So how is information being transmitted through something so small and fragile as glass? The fiber core and cladding have different indexes of refraction. This difference keeps the light from escaping the core through a phenomenon called total internal reflection, or TIR. Generally, there are two types of optical fiber, namely the single-mode fiber and the multimode fiber. They have different core sizes and index of refraction, which make light behave differently inside of the core. Single-mode fibers and multimode fibers can further be broken down to different categories. The single-mode fiber can be categorized under as OS1 and OS2. While both have the same physical dimensions, OS1 fiber has a higher attenuation per kilometer of fiber and is only suitable for indoor use, while OS2 fiber is suitable for indoor and outdoor deployment. There are 5 types of multimode fibers, which are OM1, OM2, OM3, OM4, and the OM5, with OM1 being the oldest standard and OM5 being the latest. They have different core diameter sizes and can commonly be identified based on the standard jacket color defined by various standard bodies. Each type of multimode fiber has a minimum modal bandwidth, with the latest multimode standard OM5 being able to support higher bandwidth transmission for longer distances compared to the earlier standards. Optical fiber starts as a hollow tube of glass. Gases that contain silicon, germanium, and many other chemicals are injected through the rotating tube. The glass tube is then heated by an oxyhydrogen burner that traverses its length. This creates soot deposition on the inner wall of the glass tube. Further heating at higher temperatures during rotation causes it to collapse uniformly, which results in the production of a fiber preform. A fiber preform is a rod of pure glass with a refractive index identical to that of the desired fiber. The fiber preform is then mounted at the top of a pulling tower, which feeds it through a furnace that heats the bottom of the platform until it starts to melt. The melted fiber preform then drops with the help of gravity down to a capstan, where a constant tension can be applied on the optical fiber. As more melted fiber preform is pulled, it is monitored to ensure constant diameter within the acceptable range. An acrylic coating is then applied and cured for added protection and color for identification. The fiber is then coiled onto a fiber spool, ready to be used to manufacture different types of fiber optic cables. Let's have a look at the makeup of a standard optical fiber cord. We start off with a strand of optical fiber with a layer of cladding. The cladding is then oversleeved with an acrylic coating. Aramid yarn is then layered around the assembly to increase the tensile strength of the cord. The whole assembly is then protected with an outer cord jacket that is usually made with polyurethane or PVC. Other than fiber cords, some other fiber cable construction deployed around the world are the slotted core cable, drop cable, ribbon cords, and jumper cords. The cable constructions are constantly changing to increasing market demands and requirements for deployment. Well, that's all the time we have. We hope that you were able to learn something about the various types of optical fibers and how they are made. Please like and subscribe to our YouTube channel for the latest updates, and we will see you in our next video.